organics, sulfuric acid, H2SO4.
Now, I'll blow your mind. I'm going to blow your mind right now.
Please do.
Have you heard of the Epstein files?
Never heard of it.
Okay,
Oh, this guy that he ordered 300 gallons of sulfuric
hold on.
acid for,
What
for
else? What else
my,
did he order?
my wife and I were just talking
Hold
about
on. What else did
that.
he order?
I don't know. I haven't
Calcium
deep.
carbonate.
What was the other one?
Calcium carbonate.
So he ordered sulfuric acid
Six
and
drums of 55, six 55-gallon drums. And about,
calcium carbonate. So you
now
know
is
that
it,
him and Ghislaine were way into Atlantis and ancient technology and
hold
all
on.
this type of stuff.
All right, everyone, welcome back to the land of Chem. I'm your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again. All right, everyone, welcome back. And I am absolutely pumped about today's episode, as this is the first installment of a brand new series entitled The Land of Chem Versus, where I've invited academics, career professionals, and experts from a variety of disciplines for ongoing discussions regarding the ancient physics and chemistry technology from around the world, specifically the theories presented here on the Land of Chem channel. And today I'm rocking the Land of Chem Green Lion logo, as we will be evaluating ferrous sulfate, sulfuric acid, and ancient chemical reactions. This is the Land of Chem versus Episode 1, PhD Chemist versus the function of the Great Pyramid. Ladies and gentlemen, as always, thank you all so much for the support. I think that's it for today's intro. So without further ado, let's get right to it.
All right, ladies and gentlemen, welcome back to the Land of Chem. And this is going to be the first installment of a new format here on the channel in an ongoing series of discussions where I've invited a variety of different academics and professionals from various industries and scholarly backgrounds to have discussions on the ancient lost technology of the Egyptian pyramids and other structures from around the world. My first guest on what will be called, I think I'm going to call this Versus. So this one is going to be Episode 1, PhD Chemist versus the function of the Great Pyramid. So, ladies and gentlemen, it's my pleasure to introduce Dr. Brett Cohen. And Brett and I have been in touch for, it's probably been about a year and a half, maybe 2 years since our first email communication. And Dr. Cohen, if you would, just go ahead and introduce yourself to the audience, maybe give a little background on your academic, professional, and maybe accolades in the field of chemistry. And then we can kind of go from there and then dive deep into the topic of the function of the Great Pyramid.
Okay, thank you for being here. I appreciate it. It's interesting that I am the first person in
Yeah.
your series. Hopefully, there'll be more than just me.
Yes, of course.
Basically, I got my PhD at the age of 25. I in the we I The PhD was in the area of inorganic and bioinorganic chemistry, where we basically looked at copper proteins, specifically proteins that are related to early life on Earth. And they were mollusks and arthropods, lobsters. They're blue-blooded. So if you look at a lobster, it has blue blood, not
Right.
red blood like
Yes.
us. If you bleed, it's red. Specifically, the work that I did is I was the first, uh, the chemistry that we looked at is the active site of the copper proteins. And I was able to illustrate the first example of a copper system acting like an iron or heme system. And
Yes.
this involved a hydroxylation reaction. So it's another way of introducing oxygen to the active site, as well as a methyl migration. And basically, it was the first example of a copper system acting like an iron system. The interesting thing is, 10 years after I graduated, they went back into the copper proteins and they found that exact reaction. So this specific area that I got my PhD in was called biomimetic chemistry, where we
Okay.
looked at mimicking the active site and
So,
hopefully meeting in small molecules. Like, for example, the copper protein could be the size of the Empire State Building. And specifically, the active site could be a car parked alongside the Empire State Building. We were looking at that car in terms of the chemistry as it evolves. There's
So
been a
you're a,
lot
so
of
to
examples.
summarize, you're a PhD chemist.
That is correct.
Fantastic. And so,
That's
not
correct.
to throw people down too deep of a tangent, but are you
Yeah.
also familiar with the rhetoric surrounding, the potential Anunnaki in our ancient history and the origin of the phrase blue bloods in terms of the
Yes.
ruling ancient
Absolutely.
class and the copper
Absolutely.
content in their blood? Very, very interesting corollary. And don't want to go down too far of a rabbit hole on that, but there's an interesting connection there between some of
Where
this.
early life on Earth is
Yeah,
blue blood.
the blue
And
bloods.
then
Yeah,
we evolved.
yeah.
We evolved.
Yeah, of course.
There's a species of, if you want to get into it 5 seconds, there's a species of dinosaur that actually left the oceans and then populated the land, and
Yeah,
that became heme or iron
correct. Yeah,
based.
yeah.
Okay, so basically, I was the first one to show that copper is similar to heme, and so I've published in my life about 250 papers in peer-reviewed journals,
Right.
uh, specifically like the Journal of we call it JACS. I think it's the best journal in the world. It's called the Journal of American Chemical Society, Inorganic Chemistry, Inorganic Chemistry Doctor, the Journal of Autism, Medical Hypothesis. I'll get into how that relates to me in 5 seconds. And specifically, all the research, or most of the research, is about 150 papers that are in ResearchGate. So if you look up my name and you specifically put in my name at ResearchGate, you'll see all the papers that are there. There's about
Right.
150, I think, that I have
And
presently
and
posted.
send me a link when we get done, and I'll put some links to your relative articles and ResearchGate publications. And
Okay,
I'll publish that in the video description below if anybody wants
that's
to do a
fine.
deep dive into his research. Again,
That's
there's
fine.
a
And
really
obviously, if there isn't a reprint there, you could ask for a reprint, and I could send it to you in
right.
terms of that.
And there's
Okay,
definitely
so
an interesting
basically,
connection between your work and these copper-based ancient life forms
yeah, isn't
and
it
the
interesting?
yeah,
Sure,
yes. Again,
absolutely. Maybe
totally
look
different
into it.
topic. Yeah.
Well,
Maybe
this is
maybe
what
for
it is. You
interview
learn,
interview part two.
well, it could be you learn from other sources in terms of what's going on.
Yeah.
Okay, so I would consider that my first chapter of my life. The second chapter is my professional chapter, where I basically was the chief executive officer and the vice president of dental research at a dental company. I have 16 US patents, specifically dealing with epoxies, cements, composites, polymers,
There you go.
dental instruments. Uh, what we did was we looked at restorative dentistry. So when you have, let's say, um, tooth decay, and you have a problem with your tooth, it's gone, you have to replace it with something. So my one of the products that I invented was specifically a core buildup material that was as strong as two structure. Two structure would be about, let's say, 45,000 psi, which is a hell of a lot. And the dentist would mix A and B of this particular material. It's a polymer that is reinforced with titanium. And my particular patent idea there was to have the titanium interact with the polymers. Now, there's the point. You're a chemist. You should be able to go into different areas, and I did in
Yeah,
terms of my dental career. So with
absolutely.
that, I published quite a bit of papers in the dental area. Say the Journal of Dental Research, Journal of Prosthetic Dentistry, Journal of Endodontics, Oral Health, just to name a few. And they're in ResearchGate, as I described. So if you could just
So
hit
since
my
you've
name.
had a career in the dental repair industry, on a personal note, what's your opinion on hydroxyapatite?
Well, hydroxyapatite is tooth structure. That's what it is. It's
Yeah.
calcium 10 phosphate 6 hydroxide 2. It's basically tooth structure. That's hydroxyapatite. That's
Yeah.
exactly what it's like saying your tooth.
The same
If you
chemical
look-
composition as the tooth, and it's
exactly.
recently been introduced into like toothpaste as a dental repair compound. And the reason I
Yes.
mentioned that, the we also have some. Again, I don't know how familiar you are with the breadth of my work, but we have a lot of chemical composition analysis from various structures around Egypt, including some coating compounds that were found on the outside of the Red Pyramid, a coating compound that was found on the outside of the Central Pyramid on the exterior casing stones. And then we'll dive deep into my favorite topic from the internal chemical composition of the Great Pyramid, calcium sulfate, here in just a moment. Okay, so please
Right.
continue. So we've
Okay.
done
So
academic
that was
background,
that
introduction
was
to your
my
career.
professional background, and
Yep.
then I would say my third chapter would be my son's autistic. So
Okay.
of course I have to look into that in terms
Right.
of it. Of course, why not? So basically, I was the first researcher to show that GABA aminobutyric acid, which is a neurotransmitter in the brain,
GABA. Yeah.
GABA,
Yeah. I'm
is
familiar.
associated with autism. I was the first researcher to show that. And specifically, GABA is created in the gut by two enzymes. It then goes into the liver for regulation, meaning catabolism, which is a fancy word meaning breakdown.
Correct. Yeah.
And the enzyme there is GABA aminobutyric acid transaminase, which I have shown to be inefficient, specifically resulting in higher GABA, which then crosses the blood-brain barrier, gets into the brain. It affects the axons in the corpus callosum, which is very important for language and speech, and
Okay.
why children and adults that have autism have these problems. So I published papers in the Journal of Autism, Medical Hypothesis. Many, many, many researchers have corroborated what I found in terms of high GABA and autism. And
Interesting.
specifically, just think about it. I don't have a medical background. I just have a dental. I have a chemical background.
Right.
I went into dentistry. I went into autism. And basically, I believe autism is caused by a deficiency in the liver enzyme GABA aminobutyric acid transaminase.
Interesting.
And
Well, in my opinion, chemistry is probably the one science that permeates everything in the universe. All of the fundamental processes from
and
the
physics
from the Big Bang on, correct. Yeah, and these two things
and
work in
physics.
conjunction. And this is
Right.
sort of one of the basic premises of my work and the mechanisms of operation that drive the technology across the planet in terms of ancient structures is this amalgam, to use a chemical word, between physics and chemistry and knowledge
Amalgam is
of
a dental word too.
right, right. Yeah, absolutely. And again, throw it back to the dental conversation. But yes, chemistry is such a ubiquitous science that if you're well versed in chemistry, the application thereof can branch out to so many different industries and, again,
Exactly.
therapeutic applications,
It's
biochemistry.
life. I call
Absolutely.
chemistry is life. That's
Yeah.
basically it.
And then, of course,
And
to bring
so
us
that
full
was my
circle, that's how we get to
what?
the Egyptian pyramids too.
Yeah,
Again,
well, I'm going to get there.
talking
And
about
then,
chemistry. Yeah.
yeah. And, so that was my third chapter. And I'm still ongoingly looking at the connection with GABA and autism. There's also a very interesting little connection, if you really want to hear it, specifically that high ammonia is also associated with autism.
Interesting.
And
And we're
I've
going to get
showed
to
that. Now,
ammonia here in a
I
second.
know,
That's going
I
to come up
understand.
again. Yeah, yeah.
Absolutely. The reason being is if you break down the molecule of GABA, it will form precursors like ammonia. And
Interesting.
then from ammonia, which is I published a paper on this, which was interesting. From ammonia, you could produce a chemical called like nitrous oxide,
Yes. Yeah.
and that's laughing gas.
Well, I was going to say
Some
bodybuilders
and some
take
what?
GABA.
Well, let me see.
bodybuilders and people in the fitness industry will take GABA as a supplement to increase nitric oxide and for a variety of other sleep related applications. And I've taken GABA before, and it made me feel really, really weird. I tried it like once or twice, and the physiological effect of GABA, it made me feel incredibly strange. So I do not
Well,
recommend
here,
it personally as a
no,
supplement,
no, no.
but
But
people
here's
do
the
take it.
interesting
Yeah,
thing. There are some autistics that spontaneously laugh,
sure. Oh
and
yeah.
that's why.
Well, no, it makes you feel kind of high, and
Yeah,
that's another
giddy.
reason that bodybuilders will take it because they're trying to get high off of legal drugs.
Exactly.
But yeah, if you
And
take
that's
too much
because of
GABA,
the catabolism
you'll
process,
feel pretty fucked up.
where you have GABA and you break down the GABA to form other precursors like
Yeah,
methylmalonic acid. I wrote this in a book chapter. It's all in the research gate, methylmalonic acid and ammonia. And then the ammonia could be broken down into other precursors. One of them is laughing gas, which could explain why some of the autistics spontaneously laugh. Okay,
right.
so that's the third chapter. And then the fourth chapter, I call it the my chemical perspective series, which is the alternative arena, where I've looked at, I think there's like 50 papers that I wrote on different mysteries, chemical mysteries throughout history. Like, for example, the mystery of Greek fire, the mystery of the Iron Pillar of Delhi,
Oh, that's a
the
good one.
mystery of blue holes in the ocean, the mystery of early use of chemical warfare in history, early use of chemistry,
Yeah.
the earliest use of chemistry some 200,000 years ago from Neanderthals, believe
Yep.
it or not. Um, and
So
of
there's
course,
to interrupt real quick. So there's a great story from Irish mythology. Are you familiar with the mythology of the Tuatha De Danann?
no.
The mythological gods of Ireland are said to have all of these
Okay.
magical weapons, one of which was a flaming spear weapon that had to be kept submerged in water or oil to keep it from spontaneously igniting, which, in my opinion, is a reference to white phosphorus and the
Oh,
utilization of phosphorus as an ancient chemical weapon. Because once you expose white phosphorus to air, it will spontaneously combust, and this mythological civilization from Ireland are also said to have possessed magic. And magic in the ancient world is a reference to chemistry that was not understood by the common people that weren't initiated into the science of chemistry. So that's another
sure.
fascinating tangent topic. Please continue.
Okay. And then, other examples are, let's say, there were aeroships in the 1800s. Everybody thinks it's UFOs. I showed that it could be, there's a chemical process that you could add water to something and actually produce, believe it or not, a gas that will float a balloon. That's possible. Not too many examples, but it does exist.
Yeah,
Also, I've looked at, let's say, a little bit of spiritualism, to show that a prism is a metaphor for ego consciousness. I've looked at, let's say, electrical circuit for the path of consciousness. There's a lot of nice similarities and interesting things about, let's say, an electrical circuit. Like everybody says, you're going to return home. That's what they call the electrical circuit. It could return home.
sure.
The
Yeah,
resistance could be your ego. There's so many different variables that could be
interesting.
related to one another.
Yeah,
And then, of course, which is why we're here, and it's the background of the picture I have, the pyramids. I did many papers on that too, specifically with that. And basically, if you want to get into how I got into, let's say, writing a paper that was published in Nexus magazine, which Christopher Dunn picked up,
yep,
I saw Christopher Dunn just on YouTube. I went on YouTube and I looked, and it was one of his early lectures, probably 1990. It was from his paper, his first book, the Giza power plant.
Right.
And he specifically talked about the chemistry. And I told my wife, he's wrong.
Yeah.
Doesn't
Yeah.
make sense what he's
Right.
saying.
Right.
And she said to me, what do you mean? I said, well, there's no way that he could produce this particular artifact in this chamber by the chemistry that he's proposing.
Correct.
So I
And
said,
let
all
me
right,
let me
let
let
me
me
write a
pause
paper.
right there real quick. So for anybody that doesn't know, and if you're watching the channel, how could you not know who Christopher Dunn is? But in my opinion, Christopher Dunn is the godfather of pyramid technology research. And he was really the first of anyone out there to propose a really well thought out, although, there's disagreements to be had on both sides, from an engineering perspective, detailing step by step mechanisms of operation that describe the function of the Great Pyramid. And the culmination of his research would suggest that the Great Pyramid was a hydrogen based power plant. There's a number of other mechanisms of operation involved in that theory, and we won't go too far down the rabbit hole on that. But just for anybody that doesn't know, when we refer to Christopher Dunn, he's really the first person to come up with a cohesive theory on the function of the Great Pyramid as a power plant. So again,
And an
if you're
alternative theory.
if you're watching this
So
channel, how could you not know about Christopher Dunn? So again, yeah,
that's
please
right.
please
But it's an
continue.
alternative. It's an
Correct.
alternative
Yeah.
theory.
Right.
That's the important thing. It's an
Yeah.
alternative theory. So basically, I said, hey, it's not right what he's saying chemically. As a chemist, it just, to me, it was obvious. I mean, I can't believe that his first book, I think, was published in 88, and then he published his second book, which I have no, here, do you see the book? This is his
There you
book.
go. Yeah, the Tesla connection
Yeah, I
is
have
his
no
second
financial,
publication.
I have no financial aspect in it. I have nothing to do with it, other than the fact he saw my paper in Nexus, and I
Yep.
give him credit. He was open-minded enough to say, gee, maybe I'm wrong. And I'm Appendix D, which is the paper that I wrote in Nexus in 2015.
Yep.
Now, here's the interesting, it's a nice little story. I see him give the lecture and I say, okay, it doesn't make sense chemically, blah, blah, blah. I write to him and I ask him, can I have your book? Because maybe I'm missing something. And he says, sure, I'll send you the book. I never got the book. I never got his book,
Yeah.
1988. And then when I said, all right, I purchased the book myself, went through it. I then wrote the paper, got it submitted and accepted at Nexus Magazine, which is Dustin Rose, very nice guy. And specifically, I thought that was it. Then in 2023, he wrote me and said, I'm really sorry I didn't send you the book, but I was really sick and I had problems at the time. I said, no problem. He said, I would like to publish your paper in my next book, the Tesla connection, the power
Yep.
plant.
Yep.
I said, no problem. Great. So I give him a lot of credit because in his book, he describes that he agrees with what I'm saying.
Yep.
And specifically, he was talking about introducing um, hydrochloric acid
Correct.
to one side of the
Hydrochloric acid.
chamber.
Yeah. Yeah.
And the problem is you have calcium sulfate,
Yep.
which is basically gypsum.
So let's pause before we go too far down that road, because we're going to do a deep dive into the mechanisms of operation. But let me just give people some background. So in Christopher Dunn's new book, The Tesla Connection, he has a full appendix that features a variety of different people that propose somewhat alternative theories and differing interpretations that contradict what he proposed in the book. So again, I give Christopher Dunn, I have a lot of respect for
Oh, you have
Christopher
to.
Dunn. And
Absolutely.
if it wasn't for his pioneering work, probably a lot of us, well, there's not many people that have actually proposed well thought out theories on the function of the pyramids, but we probably wouldn't be doing what we're doing today if it wasn't for the work of Christopher Dunn in the 80s and 90s. And again, you have to give this guy credit for being open to different interpretations and criticisms of his work, which is another reason why I'm engaging in this type of conversation with academics and professionals that are well versed not only in the disciplines of chemistry, but also in electrical engineering, petroleum geology. I have a good list of people from a variety of different industries, et cetera, that are going to come on. And again, we're going to talk business about the function of the Egyptian pyramids. So before we get into your hypothesis that works in conjunction with Christopher Dunn's hypothesis, how did you find out about my work?
Oh, I look on the web all the time. I look on everything, and specifically, I saw you had one thing where you talked about producing sulfuric acid
Right.
in the pyramid.
Yes.
And I wrote to you and I said specifically, and we'll get into that. Um, I, I don't want to put it this way. I don't want to say what you're saying is incorrect. It's plausible. Everything is plausible. But there are two, I would say, conceptual and practical problems with what you describe. I don't know if you want to hear it or don't hear it.
Of
I
course.
look at it, I look at it that specifically when I wrote you, I said, as just a general rule of thumb, I said, if you wanted to produce sulfuric acid, just do a dry distillation process.
Yep.
And I didn't even know that existed. Usually chemists like to mix stuff. I must have done in my life 10,000 different experiments. Everything was mixed. I mixed A and B and C and D, and you get all this different stuff. Dry distillation, I never even heard of in graduate school. I didn't even think it existed, but then I looked, it does. You could take a mineral, which is basically green vitriol, which
Yes.
has hydrated 7 waters,
Yep.
heat it up to a certain temperature, and you could produce around 11% of sulfuric acid, which is
Yep.
pretty nice.
So
It's
let's
pretty,
pause right there because this is a good introduction. So and we also talked about this. I sent you some of my links. So ferrous sulfate, otherwise known as green vitriol, is a chemical that I've extensively presented and discussed here on the land of chem in regard to the product of ancient passage chamber reaction systems from around the world, specifically structures like Newgrange, and they
right.
also have cousin structures in Ireland and Japan. These type of structures exist all around the world, and my interpretation of the curbstone of Newgrange is as an ancient rudimentary chemical formula describing the operation of the structure for the production of ferrous sulfate. And when Dr. Cohen sent me our first introductory email, he sent a copy of his paper from Nexus, and I read it and I was like, "Oh, ferrous sulfate. There's a huge connection there because that's a chemical that I've proposed was involved in this ancient chemistry technology." And we've also discussed distillation processes here on the channel of how you can convert ferrous sulfate into sulfuric acid and also render iron oxide, which can then be smelted into metallic iron. So it's a ubiquitously useful chemical for the production of a variety of different products. Metal, sulfuric acid, you can use ferrous sulfate as an iron supplement and a soil conditioner, and there's tons of different applications for this material. So it's a very, very interesting connection. And when I got your email and I read your article about ferrous sulfate, I was like, oh, I got to talk to this guy. And I'm glad we finally got to engage in this because we're talk a lot about a lot of stuff. And I don't know if you've recently seen my work on the source of hydrogen sulfide gas directly below the Great Pyramid.
No, that I didn't see.
Oh,
Is that a
we're gonna get in. We're gonna get into this in just a second.
okay?
Okay, so now, if you
All right,
would,
so specifically, if you look at that, I'm just saying, I did a literature review, and there was a German chemist in 1957 who actually, that's how I got the number 11%. He actually did the experiment. I took a year of German in college because they said as a chemist, as an undergrad, you have to be able to know how to look at the German literature. So I took a year of German. I'm not saying I speak fluent German, not even close, but I'm familiar with some of the words and the phraseology in terms of the chemistry. So specifically, this chemist found that you could produce about 11%. So in theory, the great, let's say the Egyptians or whoever, could have these huge vats of producing this sulfuric acid
Yep.
on demand. And all they do is decant off the top layer, and it's about 11% of sulfuric acid. The green vitriol that would remain on the bottom, they just reheat up,
Yep.
produce more until there's nothing left. And it goes through the process. So I sent it to you because I thought that was an easier way of forming sulfuric acid
Yeah.
than having this huge pyramid with 6 million blocks that probably took what, 20, 30, 40, 50 years to produce?
Yep.
How long do you think it took to make the pyramid?
So the conventional story is 20 years.
I know,
And
20.
I think one thing that people don't know or don't understand about the construction of the Giza pyramid complex is that the limestone blocks themselves were actually quarried directly on the Giza plateau. All right, everyone, I hope you're enjoying the video, and please remember to subscribe to the Land of Chem here on YouTube if you're interested in the physics and chemistry technology of a lost civilization and the function of the Egyptian pyramids and other ancient structures from across the world. Thank you all so much for the support. Now, back to the video. So
But
it
isn't
would,
it delayed gratification? If you
oh,
wanted
sure.
if you wanted to produce sulfuric acid tomorrow,
Yeah,
it would take you, according to you, 20 years to produce this pyramid. That's the conceptual problem I have with the idea. And obviously, we don't know. I'm not even too sure it's a power plant. But
sure.
what I specifically said was, it's like the Beatles song. I'm a
Yeah,
big Beatle guy. And there's a song, Hey Jude, take a sad song and make it better. So
yep.
I took a wrong idea that Christopher Dunn said, and I tried to make it better, or at least chemically more feasible in terms that it could be.
So on
The
the
no,
point of the timeline of the construction of the pyramids. So again, I don't know how much you've gotten into the full scope of work that I've presented on my channel and in my book. So my hypothesis is that all of the Egyptian pyramids were designed to produce various chemicals,
yeah, that I
starting with
know.
starting with the extraction of bedrock deposits of methane in the step pyramid, the red pyramid for producing aqueous ammonia, the
Yeah,
bent
we'll talk
pyramid.
about that
Yeah, we'll talk about that in a second. The
because I have a different idea of where that came from. But let's
yeah, yeah.
see.
So we the temple of Jupiter Ammon, and the deity Ammon is the etymological root word of our modern word for ammonia. I've talked about that
That's
on
right.
yeah, yeah.
And
So
they get it from a chemical, ammonia chloride.
ammonium chloride. Yeah, right. Yeah. So the
So
history of ammonia chemistry literally does date back to the dynastic Egyptians. That's where we get
absolutely.
the beginning of this modern day chemical. And then on the Giza plateau, we have the production of sulfuric acid in the Great Pyramid and the production of hydrochloric acid in the Central Pyramid. So, in regard to the duration, even if it was a power plant, you'd still be waiting 20 to 30 years to turn your power on. So, whether you're producing
I agree
chemicals,
with that, but that's
whether you're
much
producing
negative.
chemicals or
No, no,
power,
no. But the point
it's
is
still
this.
a long-term investment on the
Absolutely. But think about it
infrastructure
from a
construction. Yeah.
conceptual point of view. If you could produce sulfuric acid tomorrow morning,
Yeah.
literally tonight, by using green vitriol and dry distillation, you can't produce electricity. Let's assume it's true that they did produce electricity.
Right.
That I could believe you were going to take 20 something years to do.
Yeah.
The idea of producing sulfuric acid, which you could easily do, they knew green vitriol. The Sumerians knew that green vitriol existed.
Yeah.
So they could have done that. The other point that I'm saying is if you look at just the chemistry and where I had a problem initially with Christopher Dunn
Yeah.
was the specific idea that he was mixing two chemicals,
Right.
but he didn't talk about any mixing.
Yeah.
So
Yeah.
you had zinc chloride coming in one, hydrochloric acid we know it's wrong because you have to produce calcium sulfate. We understand that. But
So let's
hydrochloric,
let me explain that for the people that may not be too well versed in the mechanisms of operation of Christopher Dunn's work. So essentially, what you're proposing is that the dynastic, or I don't know, I don't even want to say dynastic Egyptians because I
we
think
don't even know.
we may both agree that the pyramids themselves predate the actual dynastic civilization, most likely
Hey,
much older than
yeah,
that, right? Um,
absolutely.
so the civilization who built the pyramids absolutely would have had the ability to produce chemicals on a small laboratory type scale, or even possibly a proto-industrial scale in large distillation type apparatuses and things like that. And again, I completely agree with the history and the importance of ferrous sulfate. Ferrous sulfate also, the legacy of that chemical permeates into the alchemical medieval period as well, where they were doing experiments with ferrous sulfate, ammonium chloride, all of these chemicals that existed in the ancient civilization were then readopted and sort of rediscovered and experimented with during the medieval alchemical period, which is the predecessor of our modern day chemistry, albeit with a veil of spiritual ascension and transformation and all of the stuff that goes along with actual alchemy. So, when it comes to Christopher Dunn's hypothesis on the function of the Great Pyramid, I guess one of the contentions I have with his work is that the mechanisms of operation for his theory on the Great Pyramid, he calls himself a Great Pyramid exclusionist and specifically focuses on the Great Pyramid and doesn't address the function of any of the other structures. And the mechanisms of operation that apply to the Great Pyramid don't extrapolate to the function of any of the other pyramids. So, what I've done in my work is try to address the function of each pyramid with similar mechanisms of operation based in physics, specifically the manipulation of water, temperature, and pressure, under the umbrella of industrial scale chemical manufacturing. Now, what Christopher Dunn proposes in his book and in his work on the Great Pyramid is that within the Queen's Chamber, so we have two shafts coming into the Queen's Chamber, one from the north side and one from the south side. And we'll talk about the archaeology because I have another sort of beef with that idea that we can discuss in just a second. That they were introducing through the northern shaft a solution of hydrated zinc, and through the
Zinc
southern
chloride.
shaft, yep, and then through the southern shaft was hydrochloric acid. And the mixing of these two solutions,
Yeah, but that's the thing. Just stop there.
yeah,
Nowhere does he describe the mixing.
right, right. So,
Now,
so the,
like for example, I was in graduate school.
yeah,
I ran a reaction that was so thermodynamically downhill that if I took a layer of the material and another layer of the material, I just let it sit, it wouldn't react. It has to mix.
correct, yeah,
Chemistry is in situ and mixing.
yes,
That's the key to chemistry. You have
yeah,
to get the molecules and the atoms to actually interact with each other. That's just the way it is.
yeah.
So that was my first issue. So I then said they have to be standalone. If he's correct that it's a power plant, they have to be standalone systems.
So let's go a little bit further with his. So he
Okay,
describes a chemical reaction. Let's just call it a chemical reaction, sans the mixing process that generates hydrogen. That
right.
hydrogen then flows out of the Queen's chamber up through the Grand Gallery and is amplified via a series of acoustic amplifiers that he calls Helmholtz
Modular. Yeah,
Helmholtz resonators
resonators.
that were housed in the Grand Gallery. And then there was a piezoelectric conversion of hydrogen into electricity inside of the King's chamber, with the ultimate product being electricity
Because of the piezoelectric effect of the quartz that
of
are
the
there.
quartz in the
The
granite. Right,
granite.
right, yeah.
Right.
So now we're going to go back to the actual chemistry inside of the Queen's chamber. And I've presented this extensively here on the channel as one of my objections to Christopher Dunn's work. Again, I have the utmost respect for Christopher Dunn, but
Absolutely.
you know, in any sort of discussion about novel hypotheses, just because two people disagree doesn't mean that there's not mutual respect and admiration. And sometimes these ideas, in the process of disagreement, you get closer and closer to the truth, which is what the ultimate objective of all this stuff is to set aside our egos. And going back to talking about ego, setting aside our ego in the pursuit of the highest goal, which is the truth of this ancient technology of this civilization that built these things. So there is a chemical analysis that was conducted in the 1970s by Dr. Richard Flanagan from the University of Nevada, if I'm not mistaken. It is either University of Nevada or University of New Mexico. And they found a layer of salt coating the inside of the Queen's chamber. And it was reported to be up to 1 to 2 inches thick, a pretty beefy layer.
You could actually see it. You could actually see it.
Oh yeah, and it's still,
Physically.
there's remnants of it in there today, and there's also remnants of the original. They use gypsum plaster of Paris coating on the inside of some of these chambers, and you can still see remnants of this gypsum coating that was added to the inside of the chamber. So there was this layer of salt, and they did a chemical analysis of it, and they found that it had some calcium carbonate from the limestone. Limestone is CaCO3, calcium carbonate. They also found sodium chloride, which is most likely naturally occurring rock salt in the Giza Plateau bedrock limestone. This limestone was the bottom of an ancient...
It could also be from the people that actually were there.
Sure.
Breathe.
Yeah, respiration and actual buildup of salt.
Basically give off salt all the time. And
yeah,
it's hot. It could be very hot in there. And so just an actual person could give off, and hey, they had sodium chloride, but it may actually be from the people that actually were in the chamber at any particular time over
and
time.
that was one of the explanations given by Zahi Hawass, who wrote a paper about the restoration, quote unquote, restoration processes inside the Queen's chamber, where they have to go in and mechanically remove this layer of salt off the inside of the walls that he says is from respiration and people breathing. However, the Queen's chamber is currently off limits to the public. Like, you have to get private special permission to be able to go inside of the Queen's chamber. So really the only main access into the structure is through the Grand Gallery, which I've also found remnants of this same salt compound specifically. So the third chemical found in the chemical analysis of the salt inside of the Queen's chamber is calcium sulfate. And I remember finding this in Christopher Dunn's first book, and I immediately came to the same conclusion that you did, is that there's no way that hydrochloric acid can produce calcium sulfate inside of the Queen's chamber. It's a big, I don't want to say nail in the coffin, but it's a big red flag for this process that he's described, because chemically speaking, if hydrochloric acid reacts with calcium carbonate limestone, you're going to get calcium chloride. And there was no calcium chloride discovered in this salt. It was calcium carbonate, sodium chloride, and calcium sulfate. And a reaction occurs between sulfuric acid and calcium carbonate that will produce calcium sulfate. So please proceed with explaining sort of your integration of sulfuric acid as opposed to hydrochloric acid in the existing model from Christopher Dunn.
Right. So basically, as you described, it's impossible to have it on the walls.
Right.
It's just impossible. So I said, okay, it has to be sulfuric acid that was there. And it's interesting, sulfuric acid has 2 hydrogens as part of the formula.
Yeah, H2SO4 for anybody that's interested in the specific mechanics. Sulfuric acid, H2SO4.
Now, I'll blow your mind. I'm going to blow your mind right now.
Please do.
Have you heard of the Epstein files?
Never heard of it.
Okay.
Oh, this guy that he ordered 300 gallons of sulfuric acid for.
What else? What else did he order?
My wife and I were just talking about.
Hold on. What else did he order?
I don't know. I haven't.
Carbonate.
What was the other one?
Calcium carbonate.
So he ordered sulfuric acid
Six
and
drums of 55, six 55-gallon drums, and about
calcium carbonate. So you
now
know
isn't
that him and Ghislaine were way into Atlantis and ancient technology and
all
all
that.
this type of stuff.
Not weird? It's like
So
limestone. He ordered
yeah,
limestone.
limestone and sulfuric
Why is he
acid.
ordering limestone and sulfuric acid? Doesn't make
It
sense.
doesn't
But
make well. So people were saying that you could do that to dissolve. He was dissolving bodies with the sulfuric
oh,
acid.
please.
You
It's the
it's
wrong
not the
acid, by the
it's
way.
not the right type of acid to do that. You
That's
need something
correct.
like hydrofluoric or something
That's
that's.
correct. Actually, have you ever worked with hydrofluoric acid?
I've never personally worked with it, but
I
I
have.
am familiar with how
All right, I'll give you an
aggressive and
example. I
dangerous it
have.
is. Yeah,
I've worked with hydrofluoric acid. It
it's
basically
scary
went through
stuff.
my jeans and gave me a welt on my leg. That's how strong it is. And
Yeah,
it was a drop of hydrofluoric acid.
yeah.
So specifically, sulfuric acid, maybe has a pH of, let's say, 3.5, 3. Hydrofluoric acid, which is, forget it, is pH maybe 1. I
Yeah.
mean, it's a totally different thing. But not getting into that, I just thought it was hilarious that he ordered calcium carbonate and sulfuric acid.
Are you
Those two
familiar?
together.
Are you familiar with we'll call it mythology of monoatomic gold?
Yeah, it's funny. I looked into that. I
Yeah.
looked into and specifically, I I don't know if it's chemically possible.
Right.
Now,
Well,
I know they
technically
talked about
speaking,
manna from heaven,
yeah,
and they talked about that it's gold that the Israelites had and all this stuff.
yeah,
I looked into it. I was going to write a paper on it,
yeah.
but I wasn't 100% sure that I would completely debunk it, so I didn't write the paper. But
Yeah.
I'm maybe 75% sure. I'm open 25% that maybe it does exist.
So I think
But the idea of
it's a
monatomic
misnomer.
anything
Yeah, it's a misnomer. When people say
doesn't make sense. Right.
monoatomic, gold does not exist in a single atom state. Even today with modern chemistry, the smallest we can do is nanoparticle gold, and you can create gold nanoparticles with a variety of different sizes and shapes, but it's still not
But it's
mono.
gold.
It's still
It's
gold,
gold.
right?
Right.
It's not monoatomic. It's not a single atom.
Exactly.
It's a gold nanoparticle, which
Supposedly they were talking like you could swirl it in a certain way and
yeah,
leprechauns
yeah, oh,
will be
yeah.
produced, all this stuff. I knew it
Which
was complete.
interestingly enough, are you familiar with the Lycurgus cup, the
Yeah, the
Roman artifact?
Lycurgus cup is the idea where they have light goes through and the cup will turn green or
Yeah,
turn
yeah, it
red,
turns
depending
red.
on
Yeah,
different
and,
colors.
and that's the result of a colloidal suspension of nanoparticle gold that was utilized
Absolutely.
in the glass making process. And this is super advanced chemistry. You
Absolutely.
can't just make nanoparticle gold from a metallurgical process. It
Yeah.
requires
So you're on the same page as I am with
it
that on that.
requires chemical decomposition of the gold metal particles into something much smaller, which requires aqua regia. So you would need both hydrochloric acid and nitric acid
That's
to
right.
break down the gold. And interestingly enough, one of the chemicals that you can
And
use
heat
to
it. And you have to heat
correct,
it too.
yep. And one of the
Not going to
chemicals,
break down just by the acids themselves.
yeah. And so one of the chemicals that you can use to then precipitate that dissolved gold is ferrous sulfate.
Okay.
So there's two
They
different
also use urea. Also, you
yeah,
could.
you can use sodium
Urea will
metabis
also precipitate out a solution.
yep, sodium metabisulfite,
Yeah.
urea or ferrous sulfate are three different chemicals, all of which I talk about in my work. So in the production of hydrochloric acid by utilizing sulfuric acid and salt, the byproduct is sodium bisulfate. And
Okay.
you can dehydrate that sodium bisulfate to make SMB, sodium metabisulfate, which is utilized to precipitate gold from aqua regia, which we'll be getting to that. Everybody who's chomping at the bit for me to talk about that more. We'll be getting to that more in the ultimate process on the Giza Plateau. So now back to the Queen's Chamber. and the utilization of sulfuric acid in this process within the shafts of the Queen's chamber.
All right. Before that, I just want to say I also wrote a paper which talked about the Ligurus cup, the cup with the light, the
Yeah,
different
yeah.
light.
I wish I had that
Um,
thing. I would let me get one of those, please, from Rome.
well, it's
Anybody who,
in the museum.
yeah, yeah, I know, right? I'd love to drink
Good
out of
luck.
one of those. Yeah.
Good luck. That would be good. Basically, I wrote a paper dealing with they call there's unbreakable glass.
Yeah,
There
I've
was a
heard of that as well.
concept
Yeah,
in the Romans that they had unbreakable glass.
yeah,
So I said, what could it be? And specifically, it could be a boric acid derivative that forms this unbreakable glass. And if you look at some of the Pyrex materials that are used today,
yeah.
the Pyrex, let's say, specifically chemistry, not
Yeah, they have
Chemex.
borosilicate glass, which is extremely
Exactly,
durable glassware. Yeah,
exactly. But the interesting thing in the mythology of the Romans is that the emperor threw it, and then the guy who invented it like took a hammer and he repositioned it.
right.
The the, the bore of glass, I don't think would actually do that. It may not even break, which
Yeah.
is what your whole point about with
And
that.
then
But
and
I'm
then the
just saying,
story goes that the Roman emperor that brought this chemist in then subsequently murdered the
killed the guy.
guy
That's right.
because they didn't want to have a
They
detriment
thought
to
it was
the
more valuable
Roman.
than gold.
Yeah, yeah, the Roman glassmaking industry was a huge industry.
Yeah, of
And
course.
even in my exploration of the museum, the old Cairo Museum, there are some very fascinating. One of my favorite areas of the old Cairo Museum is the glass exhibit. And they have some spectacular pieces of glassware that look just like sort of reflux condensers and condenser tubes and boiling flasks and beakers, and all of this stuff just screams laboratory apparatus. And of course, the conventional explanation, it's all for perfume.
Well,
That's what they say. All of it was for perfume, which in and of itself, the distillation of herbs and various plants is an alchemical process. It's the basis of alchemy and the science of laboratory apparatus and the distillation of herbs and the extraction of vital essential oils. All of that is directly connected to chemistry. So I find it interesting that, again, Egypt is the birthplace of chemistry, no matter how you look at it.
okay, so getting back to,
Yes. Yeah.
all right, so you have the two chemicals and they don't mix. So I had an issue. If that was my first issue. So I
Yeah.
said they had to be standalone systems. So knowing that you form gypsum on one side, I said in the southern shaft, you basically have to have sulfuric acid. That's a given.
Right.
Then I said, how do you form hydrogen gas on the northern side? So I said, why not take ammonia chloride, which is when you dissolve it in water, it's mildly acidic to begin with, and ultimately do the reaction that he said, where you take ammonia chloride would form ammonia and hydrochloric acid.
Yep.
Hydrochloric acid would then react with zinc sulfate, zinc chloride, and then you would go and ultimately produce hydrogen gas. You would produce a chemical called zinc hydride, which in the presence of acid would form pure zinc and hydrogen gas. Now, in the paper that I wrote and in his Appendix D, I talk about half reactions. I show the half reaction. There's three half reactions. So you go ammonia chloride goes to ammonia and hydrochloric acid. Hydrochloric acid and zinc chloride gives you zinc plus hydrogen gas, and then zinc hydride forms zinc and hydrogen gas. And then ultimately, that's the hydrogen gas that he's talking about,
Yeah.
which will ultimately power the plant in
So
terms of
do you
that.
know where he got the data on this zinc chloride? Because I've never seen that information published. And
I looked,
if there
I
was a
couldn't find it
zinc
either.
compound, you would think that the
Right.
zinc would have made an appearance in the chemical analysis of the material found inside the Queen's chamber. So I've always found that I don't know where that information came from. I don't know where the samples because so you don't know where that came from either?
No, I don't know. What I did is I took what he had
Right.
and I wanted to make a sad song better. And
Sure. Yeah. Yeah.
you know, chemically say, okay, this would make sense feasibly in terms of that. Now, the
Yeah.
interesting thing is they say on the northern shaft, they have way into the shaft, they have a door that has these two metal, looks like, I
So that's
guess,
the yeah, they call it Gattenbrink's door. And
that's
that's
right.
so there's again
And that could be the source of where it's supposedly zinc coated.
right.
And it is
So
possible
so let
from
me let me
certain
give
chemistry called
some
galvanic.
background on the
Yeah, okay.
configuration of the Queen's chamber for people that don't know. So they've done two different explorations, and there's another one coming up here in 2026 where they're going to send an additional robot up the northern shaft. But it was called the Jetty Project and then Gattenbrink's Door Project, where they sent a robot up the southern shaft. They found a blocking stone in the southern shaft that had,
Small. It's very small.
yeah,
Yeah.
very small. Yeah, the southern shaft,
Very
they told
small. It's
me,
not like, oh, the stone is huge.
yeah, yeah. The
It's like,
southern shaft itself is a very, very small, narrow
right,
shaft. And they found a blocking stone that had two prongs sticking out of the front face of it. They then
metal looking.
metal, they are metal.
Yeah.
They
Yeah.
subsequently drilled through the blocking stone and set a camera in there. And then there's two sort of a hook or a loop on the back end of this stone. And they call this thing Gattenbrink's door. So, so you're saying that perhaps the source of the zinc could have been from these, let's say for a better word, because I think Christopher Dunn also talks about this, that they're possibly electrodes,
Could be.
for lack of a
Could
better
be.
term. Yeah.
Right. You don't know.
Okay. So now, how familiar are you with the original configuration of the Queen's chamber?
The original, well, I did my research. I pretty much know what's going on.
And so this is
In terms,
another one of my objections with Christopher Dunn's work. So in the night, are you familiar with Wayman Dixon and the discovery of the
yeah,
Queen's chamber shafts?
yes, yes,
how
yes.
how he found them sealed with stone,
Yeah,
and,
absolutely.
and they had to break through. It's been anywhere, they say a hand is the measurement, a hand worth of stone broke through the stone to open up the Queen's chamber shafts. So the original configuration was neither open to the inside of the chamber, nor is there an inlet into the shaft because there's a blocking stone at the
That's
top.
right.
So
And
how do
it
we
doesn't go out. It
it
doesn't go
doesn't
out.
it doesn't go out and it doesn't go in. So how
Right.
do we
So
reconcile Christopher Dunn's hypothesis that there would be some sort of inlet and an outlet into the Queen's chamber when that's not actually the archaeological configuration of that component?
it's a tough one.
Right. So I wanted to ask your opinion on that because in my research and in the discovery of Gattenbrink's door and the exploration of the shaft, there is no inlet that goes into these. I don't
Well,
want
he
to call
said
them.
he also said there could be a pump or something where they pumped it in through. But
Sure.
what you say is if it was completely closed off,
Yeah,
you
it's
can't
sealed
pump
on the
anything.
inside of the chamber with stone,
Yeah.
and then it's
So it's tough.
blocked at the top of the shaft. So it's a completely sealed in
Right.
standalone component that's not open on the outside, nor is it open on the inside. So all of that being said, I did find it extremely interesting that we came to the same immediate conclusion about the presence of sulfuric acid inside the Queen's chamber because that calcium sulfate is a smoking gun for the
Oh, absolutely.
presence, and it's probably the strongest evidence that we have that there was sulfuric acid inside of that chamber. You don't just get two
And
inches of salt accumulation
absolutely.
from natural processes.
And the funny thing is, it I wrote the paper 2015. The book, I think, came out in 1998,
Yeah.
1988, 1988,
I was
or
3 years old back then.
okay.
So
I
he's
wasn't. That's okay. That's all right. But what I'm saying is nobody brought it up. It
right.
was so obvious. I
Yeah.
just was surprised that nobody would bring it up. But like I said before, I give him a lot of credit for being open
Yeah. Oh yeah.
and looking at what I wrote and what I proposed and said, yeah, I see where I went wrong. And I give him credit for that.
Well, so
You
people
have to.
also don't understand that from an academic and professional standpoint, it's like career suicide to stick your neck out there and talk about the function of the Egyptian pyramids in terms of the criticisms of your credibility, and all of this stuff basically goes out the window as soon as you talk
No, but
about.
he'll be the first to tell you. I heard him talk
Yeah.
like just very recently, and he said, "I'm not a chemist, but
Yes.
Dr. Cohen's a chemist,
Yeah.
and I believe what he's saying." So he's an engineer. Like he talked
Correct.
about, I've heard him talk about the tolerances of some of the vases and the faces and this and that and that. And I say, I have no idea what he's talking about. That's not my
Yeah. Right. Yeah. Yeah.
wheelhouse. I'm a chemist. I know chemistry. So I you can't totally bash him for saying that he went along with that. Also, I thought he got help with that. I think there was somebody who gave him uh, at least the idea that this is how you could form hydrogen gas. Let's put it that way. Let me ask you this question.
Yeah.
Red Pyramid.
Red Pyramid. Let's
Have they,
go.
I'm curious.
Yeah.
Have they found ammonia chloride in the Red Pyramid? And let me
So,
tell you why. Let me tell
yeah.
you why before
Yep.
you
Yep.
answer. The question is, or at least the point is, they used ammonia chloride as part of their rituals, worship. I guess, it's a white solid. They could easily get it from these coal dumps where they were, and they would use it as part of their ritual. It's like throwing rice at a wedding, I guess. I mean,
Yeah.
this is what they do. Have they found any ammonia chloride
So the
in the red?
chemical analysis data that we have from the Red Pyramid was collected by my colleagues at the ACIDA project 10 years ago. And they did probably 20 or 30 different samples from inside the Red Pyramid. And at the time, they were only testing for metal composition analysis. So the only data that we have on the staining shows
Okay.
the composition of metals in the material,
And
which
which
is,
metals did they have?
so it's predominantly iron oxide.
All right, that doesn't tell you much. Okay.
So then we have iron oxide, then we
Yeah.
have strontium, and then there's probably 30 other different metals in there, from zinc,
Trace, though.
from
Trace,
zinc
right?
to lead. Then we have trace elements that actually there's trace amounts of thorium, all
Yeah,
sorts of, but it's
that could be
normally,
from the earth.
it's naturally occurring in such
Yeah, that
small
doesn't mean
trace
anything.
amounts. So
Yeah.
essentially, the red
I,
pyramid limestone is very high iron content limestone, which is pretty
okay.
common in
Yeah.
Egypt. And there's also a substitution that can happen in calcium carbonate, where strontium can substitute for the calcium in the calcium carbonate, and it becomes strontium carbonate limestone. So that's where the strontium comes from. It's an actual constituent of the stone material itself.
But they haven't looked at, let's say, ammonia chloride
No, 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 we
per
don't. We
se.
don't have any data that shows the
Because I'm thinking the reason
non-metallics.
why I'm saying that is I'm thinking that maybe that was the source of the ammonia, that smell that's coming out of the Red Pyramid is
Have
the
you been inside the Red
no,
Pyramid? You
I
haven't?
haven't got, I've never been to Egypt at all. I'm
You've
just
never
saying I
been?
could have never been.
Oh, Dr. Cohen, let me
Never
be the
been.
first to invite you with open arms. I'm here waiting. Let's do this.
Uh, never been. Well, I
I,
don't know. Who
I
knows?
host, I host, I don't host, but I would be happy to offer you a private tour with access into all of the pyramids. And I also have a big group tour coming up in October, where we have private special permission into all three chambers of the Great Pyramid at night. We have private entry to Abu Sir Pyramid Complex, where there's a number of different alchemical artifacts. Have you heard about the collection bowl and the conduit and
Yeah,
collection bowl system at Abu Sir?
yeah,
Again,
yeah.
an indication that there was some sort of aqueous solutions being distributed around that facility, which I actually went to Egypt in 2017 with the objective of investigating Christopher Dunn's idea. He says the Great Pyramid is producing electricity. I wanted to go and see for myself if there was any evidence of that. So we go to Abu Sir, and I see this collection bowl and this conduit coming from the pyramid, and something was flowing into this collection bowl. And then we go inside the red pyramid, and it. So a lot of people have said that the smell of ammonia in the red pyramid comes from bats. I've been in dozens of other structures here in Egypt that have tons of bats in them, and the
And
smell
they
is
don't have.
the smell is
Yeah.
completely different. It
Well, they
is
also said COVID came from bats too.
sure, right.
So
The smell
what
inside
does
the
that
red
tell you?
pyramid is absolutely pure chemical ammonia. There's no arguing about that, especially now that we have chemical analysis data of the staining on the walls that people say also comes from bats. But the chemical
But
analysis,
aren't you a little curious? Wouldn't it be interesting to see if there's ammonia chloride, any presence of ammonia chloride in the red pyramid?
yeah. So the secondary
Because
thing
then that
is,
could explain where the ammonia comes from. It could explain it because they
yeah.
knew very versed with this chemical.
So
And
why don't you
it's
talk about the history of the temple of Jupiter Ammon and sort of the history of ammonium chloride, because this is also involved in your reinterpretation of Christopher Dunn's hypothesis, is the implementation of ammonium chloride.
well, and the thing is, ammonia chloride with his zinc chloride would ultimately form zinc, ammonia, chlorine gas, as well as hydrogen gas.
Right.
And if it's aqueous, that he's talking that it's in water, they would be dissolved. At least a large portion of them would be dissolved in the water.
Yeah.
Not all of it. That's the thing. A lot of people think that you could take a gas and just put it on in water and it's gone. You hit a supersaturation point where the molecules get so close to each other they can't even be dissolved, even though it's a gas, cannot be dissolved in the, let's say, in situ area that you have. But the thing is, what I was saying is they specifically use this chemical as a ritualistic type of worship early in their history. And like you said, the word ammonia actually comes from ammonia chloride. That's where
Yeah.
it comes from. So they knew about it, and it could be the reason why that pyramid, for some reason, maybe they really used a lot of it, that it was there. And that's why I asked about the analysis, that I was still thinking, yeah, if you found ammonia chloride, it still doesn't prove that maybe they did produce ammonia in that pyramid, but it could be
Right.
a source also of the ammonia that's there
Yeah,
with
so
that.
ammonium chloride, for people who don't know, the alchemical term during the medieval period was called sal ammoniac, which is
Yeah, right. Sal
basically
ammoniac.
an
Exactly.
ammonia salt. And that's essentially what ammonium chloride is. It's an ammonia and chloride molecule that's an ammonia
No, it's
salt.
actually ammonia, which is NH3, and hydrochloric acid
Yep.
comes together to give you NH4 chloride
Yeah.
as a solid.
All right, everyone. I hope you're enjoying the video. And if you want to help support the channel, you can pick up a copy of the book and grab some merch at thelandofchem.com. The second edition Egyptian blue version is now back in stock. Same text as the first edition, just a new color design and a brand new merch drop. Inazuma Kagaku, Lightning Chemistry. Absolutely gorgeous kanji calligraphy designed by my Japanese tattoo artist Shin at Funky Guns in Kobe, and all of your favorites, including stickers. Links to everything in the video description below. Thank you all so much for the support. Now, back to the video.
And what I say is you could dissolve that solid in water, and it's slightly acidic. So it basically is forming, meaning some of the HCl is coming off, meaning hydrochloric acid is coming off, or meaning in solution itself. So they would only have it as the solid. It would be very safe as the solid. It's like salt. It's like sodium chloride, but it's an ammonia chloride
Yeah.
derivative. Let's say you want to call it that.
So have
And
you
so
have
that's where I'm saying that it could decompose over time
yeah.
and have that ammonia smell along with it. That's what I was just saying in terms of that. Now, I wanted to bring up one other point
Yes.
in terms of your idea of producing sulfuric acid. Now, I brought up the conceptual point of view that it would take 20 years or so to build this monumental, it's the largest structure since the Eiffel Tower. Let's say it's been around forever.
Yep.
Yeah, delayed gratification and all that stuff. a lot of man hours and time and stuff. If you look at the Queen's Chamber, there's one entranceway and one way to get out. And from
Yes.
there, the aquifer, water can be pumped in to that one, let's say, uh, pipe. I don't even want to call it a pipe. It's more like
Correct. An inlet or
an
a
inlet
passageway.
passage.
Yeah.
Right. Now,
Correct.
they also have another passage that has a big block in the way.
Yes.
So
Yeah.
it's the only passage. So let's say you form your SO3. You form SO3
Yep.
in your particular process. And then it's going into that passage and it's
So let me clarify. So in my hypothesis, the King's chamber is actually the primary reaction chamber, not the Queen's chamber. The process starts in the upper chamber in the King's chamber.
okay. And then it works its way down. And when you add water to
Yes.
SO3,
Yes.
it's a highly exothermic reaction,
Correct.
extremely exothermic.
Yes.
For example, I took, in graduate school, we used to play around all the time.
Yeah.
I could take, let's say, sodium hydroxide, a pellet, and throw it in water, and throw a lot of it in water. Not mix it, right? Not mix it, and just watch the water boil.
Yeah. Oh, yeah. It's a very
Cold
violent
water.
reaction. Yeah. Yeah.
I took the cold water and I would throw sodium just to play around. I'm waiting for a reaction to mix, and I'm waiting for this and that. We used to do column chromatography, which is these huge columns, and we used to separate what they call ligands, which are basically organic compounds.
Yep.
And it would take forever. So I have time to spare. Let me see if I could boil some water. So basically, you have a beaker and you have sodium hydroxide and you put it in, and it just boils the water like incredibly. The reaction of SO3 with water is even more exothermic. It
Yep.
is highly, highly. So you then form your oleum, right? Oleum would be formed, and then it would go into the Queen's chamber, correct?
Yes.
And then you do your reaction, reconstitution reaction to get sulfuric acid. It then has to go out the same place that it came in. There's not two separate inlets, outlets.
So in regard to
And
go ahead. Go ahead.
okay, and where do you collect it?
Yeah.
Where does it collect? So you're having SO3 gas come in. You have water coming from the
Subterranean chamber.
subterranean, right, through
Yep.
the little channel that's there. You know what I'm saying?
Yeah. Yeah.
And then you have that I call it a pipe. It would be,
Yeah. Pipe. That's accurate. I
production.
agree. I agree with that term.
Okay, a pipe, and
Yeah.
then it would form oleum, and then you would reconstitute in the Queen's chamber because it's right there, and
Yep.
then you would go back. It's like,
So
wouldn't
let
it
me.
be
Yeah.
contamination?
So let me
Wouldn't it be,
let me
let's
clarify a
say,
couple things. Yes.
contamination? There would be, let's say, purity would be a problem.
Yeah.
There's a lot of issues that could be, from a chemist perspective.
Yep.
If you said to me there were two separate inlets, outlets, that would at least eliminate some of the purity issues.
Yeah.
But you could still have some oleum mixed with sulfuric acid. You could have sulfuric acid with more water, which is all right. It's water anyway. It's
Yeah.
not really a big deal with that, but still, I'm just saying it's a little problematic. It's not something that I would say is a smooth reaction.
So let me clarify some of the mechanisms of operation in my hypothesis. And then this will be kind of an interesting wrap up to the discussion, is to get a chemist's opinion on these mechanisms of operation. So I agree with the conventional hypothesis for the subterranean chamber that it is a water pump. And the subterranean chamber is used to push water into both the Queen's chamber and the Grand Gallery, filling the Grand Gallery with water up to the step. So that's mechanism number one. Mechanism number two.
Let me ask you one question.
Yes.
Have they did an analysis of the water?
Analysis of which water? The under the aquifer?
Yeah,
So I don't know that there's any. So generally speaking, I think the Ministry of Antiquities is hesitant to admit about the presence of subterranean water below these structures. And I
yeah, but
don't
you could
know.
see it. I mean, I've
And
seen pictures with a sarcophagus that down there. We
yeah,
know
oh
it's
yeah,
down there.
yeah.
The reason
And
why I'm asking is that if there are certain metals in the water or
yep,
minerals, that would affect the reaction
of course.
because that's why it would be interesting to know. Is it 100% water? Is it, I give you an example. I give you
Mhm.
an example. There was a paper that I wrote on the weirdest lake in the world. There's a lake in Indonesia that basically is like a, I don't know the exact word for it, but there's like, I have it in the paper. I'm not a geologist, so I'm just a chemist.
Right, yeah.
Basically, there's a volcano, and then it's filled in with a lake. And
Okay.
that particular lake is an acid lake.
Oh yeah, yeah.
Okay. And that you say, what's that mean? That means that lake has a pH of about 1. What's in the water?
Yeah.
All the minerals you could find. It's
Of
like
course.
the periodic table
Yeah.
because the acid from the water eats away of around where it's around. I guess it's in a volcano, so around whatever the word they have, there's a word for it. I wrote a paper on it. There's a word for that particular type of volcano. You have calcium, strontium, you got iron, copper, zinc, you name it. It's the periodic table. That particular lake, if I wanted to do a reaction with it, forget the acid part, just the water with all the metals would affect the reaction immensely
Oh, of
because you would
course.
have
Yeah.
all these byproducts occurring.
Yep.
You would have, calcium hydroxide, calcium sulfate. You could have all these different things coming, and you don't get the reaction that you want. Now, I'll
Yes.
say it this way, just one last thing.
Of course.
There's
Yeah, no
another
problem.
paper, there's another paper I wrote. You've heard of Auschwitz, right?
Yes.
Okay. Auschwitz, basically, you use Zyklon B,
Correct.
okay? And Zyklon B is hydrogen cyanide,
Yeah.
okay? And I knew I was right. I'm going to explain this. If you look at the walls of the homicidal um,
The
chambers,
chambers. Yeah.
okay, where people went in and took a shower and never came out, right? They came out dead, right? Specifically, there's no blue staining. There's no Prussian blue.
Yeah.
So I said to myself as a chemist, there's a lot of people that are denying that the Holocaust ever happened. So I have a problem with that. That's ridiculous. And they say there's no Prussian blue on the staining of the walls, but there is Prussian blue in delousing facilities.
Yeah.
I said, how's that possible? So I really looked into it and I said to myself, there has to be a competition reaction. This is what I'm getting to. And the Russians, when they went into Auschwitz, saw that they had these huge ducts that were made out of zinc. And they did a chemical analysis and it had zinc cyanide. So I said, okay, that could be a reason. It could be a competition reaction. Prussian blue is this huge, it's the paints that they used in the 1600s. Still, you could see it on the paintings.
Oh yeah. Yeah.
It's huge molecule, okay? It's cyanide. It's basically cyanide, okay? Iron cyanide. And so I looked at it and I said, gee, there has to be a way that that reaction is having a competition reaction. And so I actually balanced an equation. It took me all day to figure it out, where I looked at iron cyanide. Well, no, I looked at hydrogen cyanide, which is Zyklon B, added to building materials, which is iron material. And then basically I balanced the reaction. Now, here's the funny thing. I balanced the reaction, and guess how many hydrogen cyanides it took to balance that reaction with it's in the research gate, the
Yeah.
actual paper and everything. It took 18.
Yeah.
So you say, what does 18 mean? I have this called Chai.
Is that a yud?
It's a yud. That's
Yeah.
18,
Right.
life. It means life. And I say, yeah, that makes sense. The gods have made it that 18 is correlating to life that ultimately took people's lives. So, with that being said, you had this idea of a competition reaction. So, zinc cyanide is much easier to make than Prussian blue, which is this huge molecule with, believe it or not, in order to balance the equation, I had to have 16 waters as part of the hydrate in order to form the hydrogen, in order to form the Prussian blue, which is
Right. Yeah.
crazy.
Yeah.
So, with that being said, if you go back to the pyramids and the water itself,
Yes.
if the water has anything in it other than pure water,
Yep.
that could affect any chemistry that you're talking about. It could
Yes.
affect
So
if it
we should
has.
so we should start from the very beginning, and I would definitely like to have you on for a follow-up discussion because we can really dive deep into some of my hypotheses on the red pyramid, the production of ammonia. We can take a look at water purification. I would really love to review in depth the mechanisms of operation involved in my Great Pyramid hypothesis and get your opinion. So for me, the process starts with a structure known as Jizr el Mudir. Are you familiar with Gizr el Mudir?
No, no.
Okay, so it's a huge enclosure to the southwest of the Step Pyramid. And according
Okay.
to conventional archaeology, it's one of the first ancient structures that was built along the western bank of the Nile River. And it's a huge rectangular enclosure. My hypothesis for the function of Gizr el Mudir is as a water treatment and purification facility that was the source of the purified water that was being utilized inside these
Okay.
industrial chemical pyramids. So
Well,
we
good.
do have, let's take for step one, we do have a source of purified water. And
Yeah, but not the water in the pyramid though. That's
I
the point.
actually disagree with the hypothesis that the water comes from the subterranean aquifer. I think the
Oh,
water
okay.
comes from the external reservoir, which is also the hypothesis of John Cadman that the enclosure surrounding each of the Egyptian pyramids is actually a water reservoir that was the source of the water being utilized inside of the reaction chambers.
And what was the where did the water come from? The Red Sea? The where? Where did it come from?
So it originally would have come from the Nile. The
Okay,
Nile water would have then been
Nile is the Nile is it see, I'm not a geologist, so I don't know. If
Yep.
you told me
Yeah.
the chemical analysis, I could do something with it.
Oh yeah, yeah.
I'm not a geologist, but is it uh is it salt water? Is it
So,
fresh? I don't
you're
know.
asking fantastic questions. So we actually have some chemical analysis data from water samples that were taken inside of the Osiris shaft. Are you familiar with the Osiris
Yes,
shaft?
yes,
Yeah,
yes.
so I've been down in there in multiple private special permissions, and we were able to collect some water samples from the Osiris shaft. So the water from the Osiris shaft is from the subterranean aquifer below Giza, and it is what would be referred to as brackish water.
Which is I'm not familiar
Some
with that.
it's a mixture of fresh water and salt water. So
Ah,
brackish water is slightly saline
what's the
water.
mixture? What's the
Yeah,
mixture?
so it's got a
50-50,
so it's
25,
got
75, 90-10.
I could look back at my
That could matter,
oh yeah,
meaning
it does.
salt. Talking sodium chloride,
Oh, for
correct?
sure. Yeah, yeah. Sodium chloride, correct. And
Yeah.
there's a variety of other chemical constituents to this brackish water. The reason for that is, are you familiar with the Tethys Ocean and the formation of the Giza Plateau bedrock?
Yeah, yeah,
Yeah, so the Giza Plateau used to be the bottom of an ancient ocean
that's
millions
right.
and millions and millions of years ago. So in the foundation of the Giza Plateau bedrock, we have combination of salt water from this ancient ocean that has been gradually mixed with fresh water from the flooding of the Nile River that has infiltrated this aquifer system. So it's basically a
What is
mixture.
the percentage? What do you think the percentage is?
So I'd have to go back and look
Well, think about it. Think
at
about
the
it from a
data.
chemical perspective.
Yeah,
If
yeah.
you had salt competing, it's the same idea of a competition reaction. It happens. Chemistry is that way all the time.
Right.
Things compete with each other. That's why sometimes you have to heat stuff for it to go.
To get it to
You
go.
have to
Yeah,
heat
for
it,
sure.
or you have to
So
put
again, I
pressure
don't
on
think
it.
that the water being utilized inside the Great Pyramid comes from this aquifer, because the source of water below the Giza Plateau is filled with a variety of things that would, like you said, contaminate the chemical reaction. So it's actually
Absolutely.
a purified water source that was produced as a part of the manufacturing process ahead of time. And the
Yeah, but
water,
the thing is this, if it's sitting in limestone or whatever the material is, it's going to dissolve. It gets very hot. Let's put it this way.
yep.
It gets very hot I've seen videos where people went and it was scorchingly hot. That could affect where the water, whatever water's down there,
Oh yeah.
could actually be contaminated. And if
Oh, for
that's the
sure.
source of whatever you want for a reaction, that could be a problem. That's all I'm
Yeah.
saying.
So when it comes to
You know,
Giza
it's not hard to purify. Water's the easiest thing to purify. All you have to do is distill it. It's
distillation.
not hard. It's a
Yeah.
joke. It's
Yeah.
a joke. You know, and you have like a little residue left. I mean, it's
Yep.
nothing. I mean, it's easy. But the point is, it could get like 110 degrees at certain times during the year. And I got to believe that water is hot and it's probably dissolving materials, whatever it is. I don't know
Yeah.
what exactly is. That's why I asked, is there a chemical analysis
I do
of the
have
water?
that data. I would have to go through my list of conversations, and it would take me a minute to pull that up. And I'll prep that for the next discussion. And it will actually
Okay.
be the first time that I've publicly released the data of the Osiris shaft chemical composition analysis of the water. So on a side note, I wanted to also introduce the recent geological investigation of the Giza Plateau that discovered a source of hydrogen sulfide gas
Yeah, you said that.
coming from this naturally occurring karst cave and tunnel system below Giza.
Absolutely. You got it down in the ocean. In the ocean, they have
Yeah.
these vents come out. It's the
I-
same idea. Could be
yeah, yeah,
methane too. You'd be surprised. Could have
exactly.
methane down there.
Yeah, so I'm glad you mentioned that. So there are ancient geological processes that were happening millions of years ago that created all of these subterranean natural resources deposits all over Egypt. Egypt is a vast landscape of abundant natural resources, which is why
Absolutely.
it's the location for the construction of the biggest and best monuments that have ever been built by this ancient civilization,
And
because Egypt
preserved. And
Egypt has
preserved.
everything. It has the massive source of water. It has exceptional quality stone. It has all
Right.
of the metal ore resources. It has natural gas resources. It has hydrogen sulfide. Everything that you need for these facilities to be operational,
Well,
whether
the
they
other thing
be,
is also, I hate to interrupt, but
no,
there
no, go
are
ahead.
pyramids around the world.
Of course.
It's just not one pyramid here.
Yeah.
There's pyramids in South America. They said they found pyramids in China. There could be a pyramid in Antarctica for all we know. So
Yeah.
there are pyramids around the world.
So let me tell you an interesting story. So my wife and I also spend half of our year in Japan. We have a small house in Japan, and we go back and forth between Egypt and Japan. And I've been researching the ancient, did you know there's stone circles all over Japan?
Yes,
Yeah, stone circles, very similar to what's found in the UK. And there's also pyramids in Japan,
absolutely.
specifically one known as Pyramid Coromanta. And when they were doing the excavations of this pyramid structure, they found that there is a granite chamber inside the top of this man-made artificial pyramid mountain. And they were excavating this thing, and they cracked open the container, this granite container. They left for the day, and all of a sudden they turned back around, and there's blue flame shooting out of the top of the
Wow.
mountain, is the report of this archaeological team. And according to my research, this pyramid is built. Are you familiar with the sulfur hot springs of Japan, the onsen?
Yeah, of course.
So they're
Of course.
sulfur hot spring onsen.
Well, that could be hydrogen sulfide
Ex-
gas too, coming out of
exactly
that.
my point, right? So this is
Yeah.
kind of my research that connects these
You
sub.
probably smell the sulfur too.
Oh yeah, yeah. I've been in these things all over Japan
Yeah.
where the air absolutely smells like rotten eggs, and it's
Yeah.
supposed to have all sorts of therapeutic benefits. But this pyramid is sitting on top of a vast reservoir of subterranean geothermal sulfur gas, like result of
Probably
ancient
the same thing if you go to Iceland. Iceland has these too.
Oh yeah,
They
yeah,
have
for
these
sure.
springs and stuff just out in the nature that you have with that.
So
Specifically, I remember seeing there's a pyramid supposedly structure in Japan that it looks like it's floating, but it's like there's like
uh,
water around it or
yeah,
something like that.
it's called the Ishi no Hoden. It's known as the floating stone.
Yes,
Yeah, my
yes.
wife and I have actually been there.
I went to Chiba. I went to Chiba's Japan.
Yeah, yeah.
I had a conference there. That's the extent of my Japanese travel there.
Did you do Mount
Interesting country. Let's
did
put
you
it
do
that way.
Mount
Interesting.
Nokogiri, the granite
No,
quarry?
I actually went to Nikko.
Okay, cool.
We saw this,
Sure.
the monkeys
Yeah.
that do that, and there
Yeah.
was a waterfall. We saw that. That was interesting. And obviously Tokyo. We went to Tokyo. That was
Right, yeah.
nice.
So
Interesting.
my wife and I love Japan, and it's such a crazy juxtaposition of culture and lifestyle.
Oh, absolutely.
Living here in Egypt, which is absolute chaos, then going to Japan, which is like the epitome of civilization and
You live
polite
full
culture.
time in Egypt?
Yes,
You're a
sir.
U.S. citizen, correct?
Yeah,
You're
for
a
the
U.S.
past three
citizen?
years.
So you live in Egypt, but you also have a house in Japan.
Yes.
Wow.
So basically,
International.
I had I was the regional director for the state that I used to live in for this big corporate company. So I was basically the RD for the entire state. I also did sales and customer service.
Ah,
So I had a
okay.
nice, very, very comfortable corporate career job. And I started coming to Egypt in 2017. And, fast forward a few years, I quit my job. I sold my house. I sold my car. I sold
Wow.
everything that I own. And I moved to Egypt with 2 bags of clothes and a dream. And now I've been
Wow.
here for 3 years.
Great. You're
It's a
very brave.
pretty wild ride.
You're pretty brave.
Hey
You
man,
know,
we just got back from the US, and we were in Minnesota for a time, and let me tell you, I'd rather be in Egypt than be in some areas of the US right now.
yeah, well, that's true.
It's
I live in New York, so you probably tell from my accent.
Yeah, yeah,
So,
yeah. I'm from the
yeah.
Northeast. I'm not too far away from
Okay.
where you are. Yeah.
Okay, New York. So to me, I mean, that's brave. I mean, that's fantastic
Yeah,
in
yeah. So
terms
we
of
actually
doing
got a
that.
chance, Sally's in New Haven.
What is that?
Sally's Pizza in New Haven,
Oh, yeah,
Connecticut.
yeah, yeah.
Yeah,
Sure,
we
sure,
went up to go to Sally's in New Haven while we were up there visiting some family. I'm a Polak family in Connecticut.
sure, sure.
Yeah.
Well, that's good. That's good. But now you're in Egypt.
Yeah, so basically
Is it
after
safe? Is it safe?
I have never felt unsafe here, with the exception of some traffic sometimes and driving around. In terms of, just day-to-day activities, very, very safe. Things can get a little white knuckle when you're riding in Ubers around and, that sort of thing. But normally, generally speaking, I feel more safe here than we did kind of traveling in some areas of the US when we were there.
Mm.
Especially now that things have calmed down with the neighbors to the north, at least for the time being. That was a little bit of a tense situation. And right when that whole thing started kicking off, it just so happened that my wife and I were leaving for England and Ireland for a month. So we were leaving right as that whole situation started to unfold. So it was kind of good timing for us to get out of Dodge for a little while. And then we came back and everything was fine after that. So it's been very peaceful here. Thankfully.
Good, good. Excellent.
So
All right.
Dr.
I think
Cohen,
we pretty
dude,
much
this has been awesome. And my viewers are really, really going to love this. And if you're up for it, I would love to have you back on sometime because we can go
Fine.
much further in depth in terms of
Absolutely.
analysis of the Great Pyramid because we've both come to a similar realization that there was, if anything, sulfuric acid
Absolutely.
implemented in the operation of the Great Pyramid. And I think it would be good for me to further explain how my hypothesis works. And I think we've also kind of unfortunately not necessarily debunked Christopher Dunn, but there are some serious objections to the mechanisms that he's presented in terms of the chemical reactions and the known configuration of the Queen's chamber. It just doesn't work the way that he would suggest it would, given the known archaeological configuration.
Well, the other issue is, and he'll be the first to tell you, what did they power?
Exactly.
That's the question.
Yeah.
So take it from the end. There's a thing in chemistry called retrograde analysis. So let's say you want to form a product, E, product E. You start from E and you work your way to all the precursors that make up E. D, C, B, A. Maybe A and B are together, and then you react it with C and you end up with E. Think from the end. What did they power? That's the
Right.
question. And
Yeah.
I've heard people actually ask him, and he just can't answer it because I don't know if we know what they powered. The
I would
interesting,
agree with that. I would say there's abundant evidence for ancient chemistry in Egypt, but there's little to no evidence for the utilization of electricity as we would know it today in Egypt. We know they did chemistry, but there's absolutely no reason for us to believe that there was electrical
but
power plants for any reason.
the interesting thing is they found supposedly, I don't know, I'm not again a geologist, but they say there's a structure underneath that they were able to say this huge structure that exists. Whether
Yeah.
it's true or not, who knows? I don't really know.
So you're
To
so
me,
you're
it's
talking about
indicating,
the synthetic aperture radar scanning, and
yeah,
I've actually been in direct contact with. I know these guys, Filippo Biondi and Armando Mei. I've
okay.
attended their conferences, and I have a podcast coming up. I don't know if I'm allowed to say officially who it is yet, but I had a discussion with the lead researcher, Filippo Biondi, to sort of back and forth question and answer talking about this. What's your opinion on the validity of that and the potential for these structures existing?
My opinion?
Yeah, what's your thoughts on that?
To me, dig. That's my opinion.
Dig, yeah,
If there's
right.
something down there, dig it.
Yeah.
Dig, and it's not hard to find. We know where the pyramid is. We know
Yeah.
where it is. Just dig. But they'll never allow that.
No, no.
That's
And
the
unfortunately, these guys, they completely circumvented the Egyptian authorities in doing this project. And the way that they have presented it basically doomed their fate in terms of
yeah,
cooperation with the Egyptian
yeah,
Ministry of Antiquities.
yeah.
So they're never going to get permission to do these kind of things. You have to work through the chain of authority here. And if you don't
But
do
the
that,
bottom line is, if it did exist,
yeah.
let's assume it does.
Okay.
You could easily prove it. Yes or no.
Oh, for
There it is.
sure. Yeah.
I mean, it's not a hard thing. So it could change the whole understanding of what the pyramid's about. It
Yeah.
could. It could give you more questions that you don't know. Oh, that just adds more complexity and we don't
Of
understand it.
course. Yeah.
Or it could be that it's just not true because
Right.
they interpreted. I saw there's like little, it looks like this. It's like, it's not even pillars. It's more like blobs, I guess, if you want to describe it.
Yeah,
And
their
they
raw data is
some
very
AI or
suspect.
something.
Yeah, the raw data itself is suspect at best. Um, I was giving them a 50-50, but after my recent conversation with Filippo Biondi, the guy who developed this software, 80% bullshit, 30% maybe.
80%, 30%, so it's 110%.
No, no, 80-20. Sorry, 80-20. Yeah, I was
80/20.
70-30, now 80-20.
I see. Okay. I just
20,
say, I don't know what it is. Just
yeah.
dig. There it is. It may be people may actually You'd be surprised. People go in, they may actually dig and they don't even know. Who knows?
Oh,
So,
we know for sure that happens. And
well, you
back
never know.
to the discussion on the Giza Plateau, there is absolutely a cave and tunnel system below Giza that is one of the most important unexplored areas of this pyramid complex is this natural karst cave and tunnel system. Are you at all familiar with my work on the iron veins and the iron
No.
deposits on the Giza Plateau?
Well, that makes sense. It could be it's geological. That makes
Yeah.
sense.
So there's hydrothermal iron ore mineral deposits all over the Giza Plateau, which is a part of how this system works, in my opinion. So basically, the biggest difference between my work and Christopher Dunn's work is I think that the pyramids utilize nature's electricity to power the structures to make chemicals, as opposed to the opposite side of the coin where Christopher Dunn says they use chemicals to make power. So
Right.
we're kind of complete opposites of maybe the same coin.
Well, you also look at the Sphinx. They supposedly have the Hall of Records from Casey at the Sphinx.
Yeah.
They
Oh yeah.
should dig there too. So there's so much that could be done, but I think it's all hidden. It's this, you could look at the conspiracy idea that maybe what we think we know, we have no idea, and there was a civilization before us. There's like out of place artifacts all over the world
Oh yeah.
that don't make sense. This could be the same thing in terms of this. It could.
Absolutely. Absolutely. And it's just one of those things that now that Giza is such a monumental tourist attraction, the
Yeah.
likelihood of intensive excavation below the pyramids is slim to none. And the process of getting the permission to do that would be a mountain of obstacles to try to make that work here in Egypt.
Well,
So
they have a narrative that their narrative is they want to have it that they built it and they're great. It's like the
sure.
Romans, yes.
Yeah.
You would say, our society did it. I mean, or the Turks, or you know what I'm saying? It's just the way it is. So anything that would kill that narrative, that's the end in
Yeah.
terms of that. So it may never happen. Let's put it
So,
that way.
Dr. Cohen, do you have anything that you'd like to promote? Again, please email me some
I
links
have nothing to promote.
to your article.
No, I have nothing to promote. I have no I told my wife, I don't have a dog in this fight. I don't have that the Giza power plant is correct. What you're saying is correct, or maybe there's a third alternative. It's a tomb. Who
Yeah.
knows? And we were wrong all along. I have no alternative ideas in terms of that. I just wanted to, as a chemist, correct the glaring mistakes that were there chemically,
Right.
because that's what I could add. I can't add as a geologist. Even the chemistry, even past the chemistry, I can't add, like the physics, where you say he has the Helmholtz resonators. I can't add to that. It's
Right.
not my wheelhouse. It's not what I'm about. You talk about sonochemistry in your
Yeah.
process.
Ultrasound. Yeah.
I can't really add to that because I've never done that before.
Yeah.
I've never done that type of chemistry. Um, Maybe it's right, maybe it's wrong. I don't know. It's possible. Anything is possible. Chemistry is a weird thing. It's. I remember in undergrad, they would organic chemistry. They would only test you on the exception, not the rule. And I said, "What's the point?"
Right.
And the guy says, "You have the rule is the easy. You add A and B and you get C. That's fine. It's the exception that we're more interested in."
Yeah. Oh yeah.
So that's the point in terms of all this stuff. How it relates and what's the exception in terms of this chemistry or that chemistry. But I'm constantly looking at mysteries because I figure I could add to the mysteries
Well, I want
from
you
a
to come. I want you to come to Egypt. And please take this as an open invitation from someone that has lived here for 3 years and done numerous tours. And, I have my subscribers that have come over the past several years, and we've done big group tours and I do private tours. But I would love for you to come and see these things in person so that we could go out and investigate the mystery of the pyramids under the umbrella of this ancient chemistry. So please take that into consideration.
Okay.
I will
I'll say
definitely.
this. I'll say this. If you want to collaborate on any publications, I'm not familiar if you're in my world of publishing papers.
Yeah.
Uh, I'm a paper publisher. I like peer review. I like to be reviewed by people to get papers published. If you want to collaborate, I have no issue with that.
So that will
We're
be the
supposed to have
next.
a PhD on the paper
Yeah,
in
yeah.
terms
So
of getting
that
it
will
published.
be the next after I publish my second book in the format that I currently use. My next big step will be a formal academic publication. And at the time when I published my first book and I started doing this, I didn't have all of the chemical analysis data that we have now. I didn't have the knowledge on the electrical engineering side that I have now. So I was very much still a novice when I was starting with YouTube and publishing. And over the past, now that I look at it, it's been 6 years since I published my first book. A lot has changed with my hypothesis, as with any
Oh,
research.
obvious.
What you start with isn't always what you end with, depending on the
That's
research
right.
that you discover. So, for example, my original hypothesis is that they were using solid sulfur within the Great Pyramid for the production of this sulfuric acid. And then, lo and behold, I discover that there's a natural resource reservoir of hydrogen sulfide gas directly below the Giza Plateau that was the source of the sulfur gas that was converted into sulfur dioxide and then into sulfur trioxide for the production of this sulfuric acid product. So a
Or
lot,
you could just take green vitriol,
yeah.
and
Again,
it's a
going
much
back to the,
simpler process.
yeah.
You throw it in one of the jars that they have, the glassware that you talked about,
Oh, yeah.
heat it up to the temperatures that they're used to, and within an hour you have sulfuric acid. One step, real quick, decant it off. Hello, I have it. That's this.
So to
You
wrap
know,
up, what did you think on the, because I had sent you some videos about Newgrange and the production of ferrous sulfate. So what did you think about my work on Newgrange and the
I
ancient
think it's
alchemy of,
interesting that stone where it actually shows, like swirling
yeah,
and
yeah.
interesting.
Yeah,
Obviously
the
it's
curbstone of Newgrange, right? Yeah,
right.
this ancient
It,
chemical formula.
right. It's open for interpretation, but I could see how you could interpret it that way, where they're
Very cool.
saying, and maybe they wouldn't have the ability to write the formula. Maybe they wouldn't have the ability to write that. It's possible.
So I would
I'll give
say
you an
that they
example.
wrote it in a manner that people would be able to understand no matter how distant the civilization was.
Could be,
So they
could be,
used
could
symbols
be,
instead of letters and formulas and numbers.
could be. I don't think they knew about stoichiometry.
Sure, yeah,
For
to
everybody what
actually
stoichiometry
a
is,
balanced
it's
chemical equation that we know today. Yeah,
that's something that I don't think they understood about atoms or anything like that. I'll
yeah.
give you an example. There's a
But I will
paper that
say, what's interesting, Dr. Cohen? So on the symbol of the green lion, right, the representation of green vitriol, there are 7 stars.
seven hydrates.
The 7 hydrates. Yeah. And I was
That's right.
always wondering what the connection, usually in these alchemical symbols, there's,
Yeah, but how would they know that?
well, that's
That's the
exactly. So
question.
usually,
How would they know that?
usually when you see 7 stars in alchemy, it's referencing the Pleiades, the 7 sisters.
Oh, okay.
However, when I read your paper and I looked at the 7 hydrates, that green lion, I'm not wearing my shirt, but I have a Land of Chem logo that has the green lion with the 7 stars on it. I was like, maybe, maybe they knew about that 7 hydrate molecular formula and encoded that into the symbol. But again, the question begs, how did they know that?
Well, think about it. How do we know it? How
Yeah,
do we know that?
right.
We do, uh, you know, hydrogen analysis,
Correct.
and
Yeah.
you work it out
Advanced
in terms of the
analysis using
percentage.
modern equipment. Correct.
That's how you would know. It's not like, oh, we just said it has seven hydrates. I mean, that's just what it is.
Yeah.
Yeah, you do it through analysis. So um, it's intriguing, but I'll say it this way. Last thing is very interesting. There was another paper that I did on, the arrow ships in the 1800s. They had these ships that supposedly were UFOs and people saw them in the
Okay. Yeah.
1800s.
Yeah. Yeah. Yeah.
The
Yeah.
Sayona aviation club. In fact, one of the ships is named Trump. This guy, Charles, I forget his name, Charles something. He was basically an artist for and Mendez was the pilot. So he ended up dying, Menzies, real quick. And so they didn't know why. And he was the pilot for these airships. And the people are saying it has to do with the Glocke and,
Oh yeah,
the
the
which
mercury thorium reactor
give
of
me a break. I
yeah,
mean,
yeah.
that's insane. That's so insane. It's beyond reality. But
Yeah,
that's, mercury, red mercury,
red
whatever they
mercury, right? Yeah.
impossible. Okay, so that's that. So they had a gas called NB gas. NB gas. And this was an anti-flam, like anti-gravity gas. So I looked at it. Why? How can you produce something to float a balloon by adding water to it? And believe it or not, ammonia will do it. Ammonia is NH3
Right.
gas, very close to NB gas, NH3 gas. So it is possible that they produced ammonia. And the guy died as the pilot because he got asphyxiated by the ammonia.
By the
So
gas,
he's
yeah. All right, everyone. I hope you're enjoying the video, and please remember to subscribe to our 3 other channels. My wife Alexa's channel, Archeo Alchemy, our mutual international travel and culinary adventure channel, Let's Go with Lex and G, and the best channel on YouTube, Egyptian Trash Cats. For all you cat lovers out there, ladies and gentlemen, as always, thank you all so much for the support. Now, back to the video.
he's producing this ammonia and he's going up into the atmosphere, this balloon, and he's being asphyxiated by this gas that's there. So I'm just saying, how did they didn't know what the formula of ammonia was.
Right.
He called it NB. How did he know that? If it's NB, it's very close to ammonia. Let's put it that way. It's weird. It's just weird. So it is possible that the 7 stars relate to the hydrate. It is possible.
I
And
love
it's not eight.
the history of
It's not 8,
chemistry
and
and
it's not 6. It's
yeah,
7.
7. Yeah, yeah.
Is
So
that 8?
I love the history and science of chemistry. It's, I don't have a background in chemistry, but it's just sort of been a passion of mine, especially since I got interested in the function of the pyramids. And we have so much more to talk about. The connection of your work to these ancient copper blue bloods, the production
Oh,
of
yeah, well, that's
ammonia.
interesting. I
Yeah,
never
yeah.
knew.
So we'll
I'm
have to,
looking at it from purely the academic area in
yeah,
terms of what we did, to get your PhD and to learn the science in terms of that. I'll just say this way. I got into chemistry in 1972. I was 10 years old, and there was an astronaut on the moon. His name was Jack Schmidt. He was a geologist, a PhD. He dropped a hammer and a feather. Now, we won't get into whether we went to the moon or not.
right. Yeah.
We'll put that aside. He had a hammer and a feather, and he dropped the hammer and the feather, and they both landed at the same time. And he said the following, it changed my life forever. He said, what do you know? Mr. Galileo, 300 years ago, was right. And I said, how would a guy 300 years ago know that?
Yeah.
And that was my exploration to getting into chemistry, science. I took physics. My minor was physics and calculus with a chemistry major, PhD in chemistry. It changed my life forever. And then,
now we're on here talking about the function of the Egyptian pyramids.
well, I don't know. It's just, for me, uh, I was asked once to be on Jeff Rentz's show. Jeff Rentz?
Okay.
You've
Yeah.
heard of him.
Yeah.
And I said, maybe not. And then you sent me the email. I said, okay, let's try it out. Let's see what the story is. Because this is my first entree in this type of stuff.
Well, this is my first one too. My first, I don't want to call this a podcast, but interview type conversation. And
I actually saw you on that on what's his name? The guy, he's a young kid.
Danny Jones.
Jones, yeah, I saw you on Jones. With
Yeah,
that.
yeah. Danny.
By
Danny's
the way,
a good
did
friend.
you see that incredible one with him and Bart Sabel?
Oh yeah, yeah. I've been following that
Oh,
the moon landing one, and then they had
oh,
the old guy, the original guy who landed on the moon, and he had no
he looked
idea
to
what
me
was
like he
going
was
on. And
clueless.
Oh
And he's
man, it
saying,
was
"Well, what does this prove?"
a whole shit show.
I
Yeah.
mean, but it kills me because I told my wife, it kills me. I became a scientist because of this.
Yeah.
So I'm still holding out that it's really true.
Well, he also
How
had a
do you,
follow-up conversation with it's an excellent one with everyday astronaut, sort of
oh yeah, I've seen, right.
debunking the moon debunkers. And that was really, really good and jam-packed with, legitimate explanations for things like why we didn't go back. Well, because it was a huge financial burden on the country at the time, and there was no interest in spending that type of money anymore. Again, that's a whole other tangent that
Yeah, but that's
uh,
not human civilization. Human
true.
civilization basically creates or investigates or discovers and then populates. So it's contrary to everything we have.
Right.
The one thing that's really the problem, I don't want to really get into it, but the real problem is every other mission, Saudis and Apollo and all these others, not Apollo, I'm sorry, Gemini, Mercury, they all were in low Earth orbit.
Yeah.
Only Apollo went above because of
So,
the Van Allen radiation belts.
well,
Did he
so
talk anything
now they
about?
have this new Artemis mission that's supposed
Yeah,
to
but
be
it's
going. They keep
yeah, but
pushing it
it's
back.
right.
Yeah.
What do you think?
Yeah. So we'll see. I don't know. They're saying they're going back to the moon, but everybody's like,
No,
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 that's
they're not going
bullshit.
back. What they're doing is they're going to the dark side of the moon.
To orbit the moon. Correct.
They're not actually landing on the moon.
Correct. Yeah. Yeah. It'd be around the moon, to orbit the moon.
Right. So
Yeah.
that's a big difference in terms,
Well,
but would have to get past the Van Allen radiation belts.
yeah.
Here's the point. Let's just call it what it is. I call it there's three main issues with the whole thing. The first thing is specifically none of the plans exist. If you wanted to build exactly 1960 technology, it's all gone.
Right.
Now they say if you look at the Super Bowl, the first Super Bowl, the first one, they lost the tapes. It doesn't exist. And there were two networks that had it. So maybe they were not the greatest. The second thing, which is really the key to the whole story, is you have to get through the radiation belts. And in the Bart Sabel, they talked it was like an hour and a half to get past those radiation belts.
Yeah.
So it's a lot of radiation. And they all lived long. They all lived long.
Oh, yeah.
So it's not like they died young. And then the third thing, which to me is the key to the whole point, why didn't you go back? There's a lot of minerals. There's techno. I'll give you an example. Give you an example. You say something. If I went into academia today, I would go into a form of chemistry that doesn't even exist anymore. It doesn't anymore. It doesn't exist at all. What do you think it is? Dark chemistry.
Okay.
Do chemistry in the dark and don't have photons
Interesting.
affect the chemistry.
Okay. Yeah.
Does it matter? So if you take a thermodynamically um, reaction where you basically form a solid in light with light, ambient light, will it occur in the dark? That's interesting
Oh, that's a
because they talk,
fantastic connection to the function of Newgrange and why they utilized specific wavelengths of UV light during the winter solstice for the
sure,
completion of the chemical reaction.
sure, sure.
So that's
And
a
the
whole
reason
other it's
the reason why I'm saying
UV
that,
chemistry is another
well, not
area of
UV.
chemistry.
I'm just saying in general, they talk about the Higgs boson and this idea that there's a field
Sure,
and,
yeah.
you create all this stuff. In graduate school, I had a reaction that I actually had to take a 100-watt bulb from a lamp and put it by my reaction vessel as I mixed stuff. And that's the only way the reaction would go. So I would heat it and I would have a light source.
Interesting. Okay.
Interesting, right? And it was a nitro compound, NO2 compound, that did this particular reaction. So then I said, if I went into academia, which I didn't, I went into dental. I went into, I went into business, not business, but commercial, let's put it that way. If I was in academia, I would look at dark chemistry. I have a word for it, dark chemistry. And I believe there's a difference in reactions that occur in the dark versus reactions that would occur in the light. And I've looked literature search, nobody's done it. Nobody's looked at it, nobody's thought about it. It's not anything that's on the radar because you take it for granted that there's light.
Yeah.
And in the Bible, it says, let there be light. And then from the light, he created everything. God created everything. So the light is important. And maybe that helps you in terms of your particular scenario that you brought up.
And going back full circle to the Big Bang, the creation of the universe, and the fundamental sciences of physics and chemistry that are the basis for our reality. Dr. Cohen, what a fantastic first episode, breaking your cherry and popping my cherry here on the Land of Chem for this interview.
I hope I didn't kill you too much.
No, this is awesome. Again, I always say that in terms of feedback from qualified professionals, if anything, it helps to sharpen my sword and make me better at doing what I'm doing. And at the end of the day, I am in the pursuit of truth, whether that be Dunn's theory or my theory or some combination thereof or something we haven't thought of. I want to get to the bottom of this pyramid mystery. And by pushing the envelope forward and people proposing novel hypotheses that are different from each other, we will be able to get closer and closer to what the true function of these structures were. So this was a fantastic conversation. I would love to have you on for part 2 so we can do a deep dive into the actual hypothesis that I presented. And please send me some links. I'll put links to everything.
Well, I don't know what that means. All you have to do is go on ResearchGate.
I'll find it. Yeah.
And
so it's just
my
links.
name, and you'll see 150 some odd papers.
Yeah. Is your Nexus article available in that ResearchGate publication stack?
Yes.
Okay. So I'll put a link to the whole research stack in the video description below.
Yes,
a link is basically a website link where they can click to see all your publications and read your material.
I don't have the ResearchGate is not me. I just have my
yeah.
It says who I am and all the stuff that I have and all the patents, my 16 patents and all the papers that I have. It's not all the papers. I only have I think the total is 151 or something. There's another 100 that I don't think they're important, but they're not as important as the ones that are there now. And I have a lot of the alternative papers, what I call the chemical perspective series. And that's all the mysteries, that we talked about, all the different, other than this.
And everyone, I highly recommend reading Dr. Cohen's Nexus paper regarding the utilization of ferrous sulfate for dry distillation and the production of sulfuric acid. Dr. Cohen, thank you so much for coming on. This has been a thrilling discussion. I'll be in touch. Let's do part 2, and I'll talk to you soon, sir.
No problem. Take it easy. It was a pleasure. I was happy to meet you.
It's fantastic to finally do this. Yeah, I'm really excited. This was awesome.
Great. Have a good one.
Okay, we'll talk to you soon. Have a good night, sir.
Take it easy.
All right. Cheers from Egypt.
All right, everyone. That is it for today's video. This was the Land of Chem versus Episode 1, PhD Chemist versus the function of the Great Pyramid. I really hope you enjoyed today's video. And in the next episode in the Land of Chem versus series, Mechanical Engineer versus Ancient Lightning Technology, featuring the one and only Andy Hall. This is an episode you do not want to miss. So if you haven't already, please subscribe to the Land of Chem here on YouTube if you're interested in the ancient physics and chemistry technology from around the world and the function of the Egyptian pyramids. Please remember to click that little notification bell so you don't miss out on new episodes. Like, comment, share, hype, and stay tuned. If you want to help support the channel and get access to exclusive research content, check out the Land of Chem members only channel and thelandofchem.com. If you want to pick up a copy of the book or grab some merch, links in the video description below. If you want to follow me on Instagram or on X, my handle is @thelandofchem. Also, don't forget, after you finish watching this video, please go subscribe to our 3 other channels. My beautiful wife Alexa's channel, Archeo Alchemy, our mutual travel adventure and culinary experience channel. Let's go with Lex and G. And the best channel on YouTube, Egyptian Trash Cats. For all you cat lovers out there, ladies and gentlemen, as always, thank you all so much for the support. I think that's it for today's episode. So I will see you next time.
Yo, are you still watching this? Please subscribe to the Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.